Q51. In Anypoint Platform, a company wants to configure multiple identity providers, IdPs, for multiple lines of business lobs. Multiple business groups, teams, and environments have been defined for these lobs. What Anypoint Platform feature can use multiple IdPs across a company's business groups, teams, and environments? A. MuleSoft hosted CloudHub dedicated load balancers. B. Client application management. C. Virtual private clouds. D. Permissions. The correct answer is B. Client application management. Explanation. Why B is correct. Client application management in Anypoint Platform allows organizations to configure multiple client identity providers, IdPs, such as Ping Federate, OpenAM, Okta, or custom OAuth 2.0 servers at the root or business group level. This feature allows different lines of business, lobs, teams, and environments to use distinct IdPs for authorizing client applications and enforcing API security policies, like OAuth 2.0 or client ID enforcement. Why A is incorrect. Dedicated load balancers, DLBs, are networking components used for routing HTTP/HTTPS traffic to CloudHub workers and managing custom certificates. They do not manage or configure identity providers across business groups. Why C is incorrect. Virtual private clouds, VPCs, isolate networks for CloudHub worker deployments. They have no role in managing identity providers or user/client authentication. Why D is incorrect. Permissions and team/roles are used within Anypoint Access Management to control user authorization and access to platform resources, but they do not configure or serve as the mechanism to integrate multiple external client identity providers across lobs and environments. Q52. An organization is designing a Mule application to support an all-or-nothing transaction between several database operations and some other connectors, so that they all roll back if there is a problem with any of the connectors. Besides a database connector, what other connector can be used in the transaction? A. VM. B. Anypoint MQ. C. SFTP. D. Object Store. The correct answer is A. VM. Explanation. Why A is correct. In Mule 4, only specific built-in transactional connectors support participating in single resource or extended architecture, XA transactions. The VM virtual machine connector, along with database and JMS connectors, fully supports transactional actions, such as always_join or begin__join, allowing to participate in an XA transaction alongside database operations, so that all operations commit or roll back as a single atomic unit. Why B is incorrect. Anypoint MQ does not participate in Mule's standard XA or single resource transactions. While Anypoint MQ supports message retries and acknowledgments, it cannot join an all-or-nothing transaction with a database connector. Why C is incorrect. SFTP is a file transfer protocol connector that does not support transactional boundaries or two-phase commit XA protocols. Operations on SFTP endpoints cannot be rolled back atomically alongside database changes. Why D is incorrect. Object store operations in Mule Runtime do not support transactional management or XA transaction enlistment. Key value operations on object store persist independently of flow-level transactions. Q53. A company is planning to migrate its deployment environment from on-premises cluster to a Runtime Fabric RTF cluster. It also has a requirement to enable Mule applications deployed to a Mule Runtime instance to store and share data across application replicas and restarts. How can these requirements be met? A. Anypoint Object Store v2 to share data between replicas in the RTF cluster. B. Install the Object Store pod on one of the cluster nodes. C. Configure Persistence Gateway in any of the servers using Mule Object Store. D. Configure Persistent Gateway at the RTF. The correct answer is D. Configure Persistent Gateway at the RTF. Explanation. Why D is correct. In Runtime Fabric RTF, persistent object stores require setting up Persistence Gateway. Persistence Gateway bridges RTF to a customer-managed database, such as PostgreSQL, enabling Mule applications running on RTF to store, persist, and share data across application replicas and worker restarts. Why A is incorrect. Object Store v2 OS v2 is a cloud service managed directly by MuleSoft for CloudHub deployments. It is not natively available for application instances running on Runtime Fabric RTF clusters. Why B is incorrect. There is no Object Store pod component that can be manually installed directly on individual cluster nodes to manage cross-replica application persistence in RTF. Why C is incorrect. Persistence Gateway is configured at the Runtime Fabric cluster level, connected to an external persistent data store, not on individual underlying servers using Mule Object Store. Q54. Following MuleSoft best practices, what MuleSoft runtime deployment option best meets the company's goals to begin its digital transformation journey? A. Runtime Fabric on VMs/bare metal. B. CloudHub Runtimes. C. Customer-hosted runtimes provisioned by a MuleSoft services partner. D. Customer-hosted self-provisioned runtimes. The correct answer is B. CloudHub Runtimes. Explanation. Why B is correct. Following MuleSoft best practices, CloudHub Runtimes, fully managed integration platform as a service/IPs, offer the fastest time to market, lowest operational overhead, and maximum flexibility for organizations embarking on a digital transformation journey. CloudHub allows teams to focus entirely on designing and building API-led connectivity without the burden of provisioning, managing, or maintaining underlying infrastructure. Why A is incorrect. Deploying Runtime Fabric on VMs or bare metal requires significant initial infrastructure setup, container orchestration management Kubernetes, and administrative overhead, which slows down initial progress at the start of a digital transformation. Why C is incorrect. Relying on third-party partners. To provision customer-hosted runtimes adds unnecessary architectural dependency and operational complexity compared to adopting MuleSoft's out-of-the-box managed CloudHub platform. Why D is incorrect. Self-provisioning customer-hosted runtimes requires setting up local servers, manual patching, custom load balancing, and dedicated operations teams, contradicting the goal of accelerating digital transformation with minimal infrastructure management. Q55. Which component of Anypoint Platform belongs to the platform control plane? A. Runtime Fabric. B. Runtime Replica. C. Anypoint Connectors. D. API Manager. Q56. When a Mule application using VM is deployed to a customer-hosted cluster or multiple CloudHub workers, how are messages consumed by the Mule engine? A. In non-deterministic way. B. By starting an XA transaction for each new message. C. In a deterministic way. D. The primary only in order to avoid duplicate processing. The correct answer is A. In non-deterministic way. Explanation. Why A is correct. When a Mule application utilizing virtual machine VM queues is deployed across multiple workers, CloudHub, or multiple nodes in a customer-hosted cluster, VM queues operate in a distributed manner. The Mule engines across these nodes can currently poll and consume messages from the shared queue, making the exact consumption order across multiple instances non-deterministic. Messages are processed concurrently and may not be picked up in strict FIFO order across nodes. Why B is incorrect. VM queues do not automatically initiate XA, extended architecture, transactions for every message by default. Transactions must be explicitly configured on the VM listener/operation if required. Why C is incorrect. Message consumption across multiple cluster nodes or CloudHub workers is inherently non-deterministic due to parallel worker polling, thread scheduling, and network latency across runtime instances. Why D is incorrect. In a multi-worker CloudHub or cluster deployment, VM queue consumption is distributed across all active workers/nodes, not restricted to a single primary node, to allow load, distribution, and parallel processing. Q57. Organization wants to achieve high availability goal for Mule applications in customer-hosted runtime plane. Due to complexity involved, data cannot be shared among different instances of same Mule application. What option best suits to this requirement considering high availability is very much critical to the organization? A. The cluster can be configured. B. Use third-party product to implement load balancer. C. High availability can be achieved only in CloudHub. D. Use persistent object store. The correct answer is B. Use third-party product to implement load balancer. Explanation. Why B is correct. When Mule runtime instances are configured as a Mule cluster option A, they automatically form an in-memory Hazelcast data grid that synchronizes state, shares object store data, and replicates VM queues across all nodes. Since the scenario explicitly specifies that data cannot be shared among different instances, a traditional Mule cluster cannot be used. Instead, deploying independent Mule runtime instances in a server group behind an external/third-party load balancer, such as Nginx, F5, or AWS ALB, provides high availability and fault tolerance by routing traffic across instances without sharing or replicating data between them. Why A is incorrect. Setting up a Mule cluster automatically enables shared memory grids, replicated object stores, and distributed VM queue state across nodes, violating the key constraint that data must not be shared between instances. Why C is incorrect. High availability can easily be achieved for a customer-hosted on-premises or private cloud, runtime planes using server groups combined with load balancers, active-passive configurations, or Kubernetes orchestration runtime fabric. High availability is not exclusive to CloudHub. Why D is incorrect. Using a persistent object store across instances actively shares state and persistent application data between runtime instances, directly contradicting the requirement that data cannot be shared. Q58. An organization has defined a common object model in Java to mediate the communication between different Mule applications in a consistent way. A Mule application is being built to use this common object model to process responses from a SOAP API and a REST API, and then write the process results to an order management system. The developers want Anypoint Studio to utilize these common objects to assist in creating mappings for various transformation steps in the Mule application. What is the most idiomatic, used for an intended purpose, and performant way to utilize these common objects to map between the inbound and outbound systems in the Mule application? A. Use JXB XML and Jackson JSON data bindings. B. Use the WSS module. C. Use the Java module. D. Use the transform message component. The correct answer is D. Use the transform message component. Explanation. Why D is correct. The transform message component powered by DataWeave is MuleSoft's primary, most idiomatic, and highly performant tool for transforming data formats and mapping between systems. Anypoint Studio natively reads Java class definitions, including POJOs and common object models, to populate the graphical mapping interface in the transform message component. This allows developers to visually map data fields to and from Java objects using DataWeave, which compiles directly to efficient native byte code at runtime. Why A is incorrect. Manual serialization and deserialization using JXB or Jackson data binding libraries is a legacy pattern that adds unnecessary boilerplate code and performance overhead compared to DataWeave's built-in engine. Why B is incorrect. WS Security, WSS, module is designed specifically for SOAP web service security features, such as signing and encrypting XML messages, not for object mapping or transformations. Why C is incorrect. The Java module is intended for invoking custom Java methods and instantiating Java classes when standard DataWeave functions are insufficient. Using it for data mapping requires writing custom Java transformation code, which bypasses Anypoint Studio's visual mapping capabilities and DataWeave's optimization. Q59. A manufacturing company is planning to deploy Mule applications to its own Azure Kubernetes service infrastructure. The organization wants to make the Mule applications more available and robust by deploying each Mule application to an isolated Mule runtime in a Docker container, while managing all the Mule applications from a MuleSoft hosted control plane. What is the most idiomatic, used for its intended purpose, choice of runtime plane to meet these organizational requirements? A. Anypoint Platform Private Cloud Edition. B. Anypoint Runtime Fabric. C. CloudHub. D. Anypoint Service Mesh. The correct answer is B. Anypoint Runtime Fabric. Explanation. Why B is correct. Anypoint Runtime Fabric, RTF, is containerized deployment software designed specifically to run Mule applications on customer-managed Kubernetes environments, such as Azure Kubernetes Service /AKS, Amazon EKS, or self-managed Kubernetes. RTF packages each Mule application into its own isolated Docker container /Mule runtime instance, while seamlessly connecting to and being managed from a MuleSoft hosted control plane. Why A is incorrect. Anypoint Platform Private Cloud Edition, PCE, hosts both the control plane and runtime plane locally within customer infrastructure. It does not utilize the MuleSoft hosted control plane as requested. Why C is incorrect. CloudHub is a fully managed IdPs where applications run on AWS. Infrastructure managed entirely by MuleSoft, not on the customer's own Azure Kubernetes Service, AKS, cluster. Why D is incorrect. Anypoint Service Mesh is used to extend Anypoint Platform API management and governance to non-Mule microservices running inside a Kubernetes cluster, rather than serving as a runtime plane for deploying containerized Mule applications. Q60. A platform architect includes both an API gateway and a service mesh in the architect of a distributed application for communication management. Which type of communication management does a service mesh typically perform in this architecture? A. Between application services and the firewall. B. Between the application and external API clients. C. Between services within the application. D. Between the application and external API implementations. The correct answer is C. Between services within the application. Explanation. Why C is correct. A service mesh is a dedicated infrastructure layer that manages internal service-to-service communication, east-west traffic, between services within the application. It provides features such as service discovery, traffic shaping, mutual TLS, MTLS, encryption, retries, circuit breaking, and distributed tracing across microservices running inside the environment. Why A is incorrect. Firewall communications are handled by network security policies, firewalls, and ingress controllers, not by a service mesh proxy layer. Why B is incorrect. Managing communication between external API clients and the internal application, north-south traffic, is the primary responsibility of an API gateway, which sits at the edge of the network as a single entry point. Why D is incorrect. Connecting to external API implementations outside the application network is typically managed via API gateways, egress proxies, or direct HTTP/REST client integration components, rather than an internal service mesh.
If this video helped clear up these MuleSoft concepts for you, please hit that like button and subscribe to the channel. It really helps support the content. But don't go anywhere just yet. Stick around and jump straight into the next video to keep building your integration skills.